All right, quantum physics. I know what you're thinking. This sounds really complicated,
Yeah, it kind of does.
but I promise this deep dive is going to make it, well, understandable and interesting.
Yeah.
We're looking at this fascinating text titled Shi Eratai. I
Oh,
know, right? The title's in its original language adds a bit of intrigue, don't you think?
definitely.
So, for a long time, physicists thought they had it all figured out, you know?
Yeah.
Classical physics seemed to explain pretty much everything, like planets, pendulums, all that.
It did seem that way, yeah.
But then, well, things got a little quantum.
Yeah, you see, scientists started looking really closely at the microscopic world,
Uh-huh.
and they noticed some cracks in the foundation of classical physics.
Oh, like what?
Well, light, for example,
Yeah.
sometimes acted like a wave, like ripples,
Okay.
but then other times it was like a particle, like a tiny, tiny packet of energy. And this wave-particle duality, it just didn't fit with classical physics.
That's kind of weird, right? Like, make up your mind light.
Right. So where do we even begin to unravel this quantum mystery?
Good question.
Well, I guess our journey starts with Max Planck.
Planck.
Yeah, Max Planck, back in 1900, he dropped this, like, huge E idea.
Okay, I'm listening.
He said energy, which we always thought flowed smoothly.
Yeah.
He said it actually comes in tiny little packets, like little bundles of energy.
So not like pouring water from a pitcher, but more like, I don't know, dropping marbles one by one.
Exactly. That's a great analogy. And that idea, that energy is quantized, it shattered everything.
Wow.
It opened up this whole new way of looking at the universe.
So Planck kind of started this whole quantum revolution.
He really did, yeah.
But wasn't Einstein in on this too?
Oh, absolutely. He tackled this big mystery called the photoelectric effect.
The photo what now?
So scientists had observed that if you shine light on metal,
Okay.
it could actually knock electrons loose.
Really?
Yeah, creating an electric current. But here's the weird thing. Only certain colors of light worked. Like what?
Yeah, like no matter how bright the light was, it was
Wow.
like the electrons were being picky about what kind of light they wanted to respond to.
That is strange.
Right. So Einstein, he came up with this brilliant idea.
Okay, what do you say?
He said that light wasn't just a wave, it was also a particle, a stream of particles.
Okay.
And he called these particles photons.
Photons.
Yeah, and each photon carried a specific amount of energy, and only the photons with the right energy, the right color, could knock an electron loose.
So it's like each photon is like a tiny delivery truck bringing a package of energy to the electron.
Perfect. That's exactly it. And that's how Einstein solidified this concept of wave-particle duality.
That light can be both a wave and a particle. That's pretty wild.
It is. It's one of the cornerstones of quantum physics.
So we've got energy coming in packets, light acting like, well, two things at once.
Yeah.
But I have a feeling things are going to get even weirder.
Oh, you have no idea. Get ready for superposition.
Superposition, okay. And to understand that, we got to talk about Schrodinger's cat.
Oh, the cat that's both alive and dead.
That's the one. Now, it is just a thought experiment,
Right.
but it perfectly illustrates superposition.
So how does it work?
Imagine a cat inside a box.
Okay, there's a cat in a box.
And there's also this device that has a 50-50 chance of, well, releasing deadly poison.
Oh, no. Poor cat.
So it's like a coin toss.
Yeah, a quantum coin toss with the cat's life on the line.
Exactly. Until we open that box and look inside, we don't know if the cat's alive or dead.
Right.
And according to quantum mechanics, the cat isn't in one state or the other.
What do you mean?
It's in both states at the same time. It's alive and dead simultaneously.
Wait, hold on. It's not that we just don't know. You're saying the cat is actually both alive and dead.
That's the mind-blowing part.
My brain hurts.
I know, right? Our everyday experience tells us that things have definite states.
Yeah.
A light's on or off, a coin is heads or tails.
Uh-huh.
But in the quantum world, things can be in this blurry, undefined state.
Until we look at them.
Exactly, until we measure them.
So it's like by observing something, we force it to choose a state.
That's one way to think about it. But what actually happens during measurement, well, physicists are still debating that.
So energy packets, light being both a wave and a particle, and now superposition.
We're just getting started.
What could be weirder than a cat that's both alive and dead?
Buckle up, because next we're talking about entanglement.
Entanglement.
Imagine two particles linked so tightly that no matter how far apart they are,
Okay.
what you do to one instantly affects the other.
Instantly. Even if they're like galaxies apart.
Yep, that's the spooky part.
But that means they'd have to communicate faster than light, right? Is that impossible?
So you would think so. Even Einstein called it spooky action at a distance.
So how is it even possible?
That's the million-dollar question. It challenges everything we thought we knew about the universe.
This is blowing my mind, I gotta be honest.
I know, right? Quantum physics is a wild ride.
So how do we explain this spooky action?
Well, there are a lot of different interpretations. Some suggest a connection that goes beyond space and time.
Whoa.
Some say there might be a hidden communication channel we haven't discovered yet.
This is all so crazy, but I kind of love it.
Me too. It's like we're peeking behind the curtain of reality and seeing how the universe really works.
Exactly. This is why we do these deep dives.
Absolutely.
All right, so we've got energy packets, wave-particle duality, superposition, entanglement.
And we're just scratching the surface.
Can't wait to see where this goes next.
Me neither. There's so much more to explore in the quantum world.
It's gonna be good.
It is. It's wild, isn't it? All these things that sound like they're from Star Trek, they're actually the foundation of, like, our whole modern world.
I know, right? It's like
Yeah.
magic is real, but it's quantum mechanics instead of like spells and potions.
Exactly. We thought classical physics had it all figured out, but then, bam! Light's a wave, A and D a particle, energy comes in these little packets, superposition, entanglement. It's a whole different set of rules.
But those rules, they're what make our smartphones and computers possible.
Right.
It's crazy. So before the break, we were talking about how quantum mechanics has led to all this amazing technology. Like, what kind of real-world impact are we talking about here?
Oh, huge impact. Think about semiconductors, those tiny chips that are in, well, everything electronic these days.
Sure.
They rely completely on quantum mechanics.
So, like, my phone wouldn't even work without quantum physics.
Nope. Without it, electronics would be, well, huge and super inefficient, if they even existed at all.
So every time I'm scrolling through TikTok, I'm actually using quantum mechanics.
You got it. And it's not just about making things smaller and faster. Quantum mechanics has totally revolutionized medicine and energy, too.
How so?
Lasers, for example.
What?
They use quantum properties of light, and they're used in, like, everything from surgery to barcode scanners
Wow.
and MRI scans. Those let doctors see inside the body without cutting you open.
Right.
Those rely on nuclear magnetic resonance, which is another quantum phenomenon.
Huh. I never knew that.
Even solar panels, you know, the things that are like saving the planet,
Yeah.
those wouldn't exist without our understanding of how electrons interact with light at the, you guessed it, quantum level.
So basically, quantum mechanics is way more important than most people realize.
It's everywhere. But it's still evolving, too.
What do you mean?
There are still areas where we're making breakthroughs, like quantum computing.
Quantum computing.
We talked about it briefly earlier, but it has the potential to be, like, totally game-changing.
Okay, remind me how it works again.
So normal computers, they use bits, which are either a 0 or a 1, like an on or off switch.
Gotcha.
But quantum computers, they use qubits.
Qubits.
And because of superposition, a qubit can be 0, 1, OR, both at the same time.
Both at the same time.
Yeah. So a quantum computer with just a few hundred qubits could do calculations that would take a regular computer, like longer than the universe has existed.
Seriously, what could we even do with that kind of power?
Oh, so much. We could design new drugs and materials, simulate complex biological processes to, like, really understand diseases, or even create AI that's as smart as humans.
That sounds incredible, but also a little scary.
Yeah, there are definitely ethical considerations.
Like what?
Well, quantum computers could potentially break the encryption that keeps our online information safe.
Oh, no.
It's like a race to develop quantum-resistant security before the wrong people get their hands on this technology.
It's kind of unsettling.
It is, but it's important to think about these things as we move forward.
For sure. So what else is going on in quantum tech research?
Another cool area is quantum communication, which uses entanglement.
You mean that spooky action at a distance?
Yep. We could use it to create super secure networks.
How?
Because entangled particles are linked. If someone tries to eavesdrop, it would change the particles and alert both the sender and receiver.
So it's like a built-in alarm system for messages?
Exactly. And we could use entanglement for other things too, like ultra-sensitive sensors that could detect tiny changes in gravity, magnetic fields, or even temperature.
Whoa. That would be useful for so many things. But I gotta ask, how does entanglement even work? I still don't get how two particles can be connected like that, no matter how far apart they are.
It's a big mystery. There are tons of interpretations.
Like what?
Some say it means there's a connection that goes beyond our understanding of space and time.
Okay, that's kind of trippy.
Right. Others think there might be some hidden communication channel we haven't found yet.
Like a secret code the universe is using.
Maybe. The more we learn about quantum mechanics, the more we realize how much we don't know.
It's kind of humbling, in a way.
It is. It really makes you rethink everything.
You know, for all the cool tech stuff, it's the big philosophical questions that really get me thinking.
Yeah, me too.
Like, if the quantum world is so different from our everyday experience, what does that even mean for reality itself?
It's a huge question, right? It makes you wonder about things like free will and consciousness, and even the meaning of existence.
I know, right?
It's like quantum mechanics is forcing us to confront the biggest mysteries of the universe.
It's definitely making us rethink everything we thought we knew.
It is, and that's what makes it so exciting.
So, we've been through the quantum ringer, haven't we? Energy packets, wave-particle duality, superposition, entanglement.
It's been quite the journey.
It really has. And all this, it's not just changing technology, it's changing how we think about reality itself.
It really is.
Like, if reality at the quantum level is so different from what we experience every day,
Yeah.
does that mean we need to, like, totally rethink what's real?
It definitely raises that question, yeah.
Right. For centuries, we've believed in this deterministic universe, Everything happens because of cause and effect.
Yeah.
But quantum mechanics throws in this randomness, probability,
Exactly.
because we can't say for sure what a particle will do.
Nope.
We can only talk about the chances of different outcomes,
Right, and that has huge implications.
like for free will.
Exactly. If the universe isn't completely predetermined, does that mean our choices aren't either?
Why?
Does quantum randomness give us, like, space for free will to actually exist?
That's a mind-blowing thought.
It is.
But it's not just free will, right? What about the role of the observer in all this?
Ah, yes, the measurement problem.
That's the idea that our observation, actually affects the outcome of a quantum event.
Exactly.
But how is that even possible?
That's the million-dollar question. And there's still no definitive answer.
Okay, so what are some of the theories?
Well, one is the Copenhagen interpretation.
Okay.
It says that a quantum system is in this superposition of states until it's measured. And that act of measuring, it forces it to collapse into one definite state.
So it's like we're creating reality just by looking at it.
That's how some physicists interpret it, yeah.
That's wild.
It is. But others say consciousness isn't necessarily required.
Really?
Maybe any interaction with the environment is enough to cause that collapse.
So it doesn't have to be a conscious observer.
Maybe not.
Or maybe there's something else going on entirely, something we haven't even thought of yet.
Exactly. That's what's so exciting about quantum mechanics. There's always more to discover.
It's like we're just starting to scratch the surface of understanding how the universe really works.
And the more we learn, the more questions we have.
It's a never-ending journey of discovery.
It really is.
But even with all the mysteries, one thing's for sure, quantum mechanics is changing the world.
Absolutely. From technology to philosophy, it's impacting everything.
And who knows what amazing breakthroughs are still to come.
I can't wait to find out.
This has been an incredible deep dive. Thank you for joining us.
This has been my pleasure.
We've gone from the basics of quantum mechanics to some pretty mind-blowing implications.
We've covered a lot of ground.
We've seen how it's shaping technology and challenging our understanding of reality.
And hopefully spark some curiosity in our listeners.
Exactly. Because the quantum world is vast and mysterious, and there's always more to explore.
So keep asking those questions, keep learning, and keep an open mind.
Couldn't have said it better myself. Thank you for joining us on this deep dive into quantum physics.
Until next time.
Keep exploring.